I have never told anyone what I felt that morning. My name is Carl Friedrich Gauss. I am called the Prince of Mathematics. In 60 years, there was nothing in mathematics that could stop me. That morning, something stopped me. The young man at the blackboard was 27 years old. His hands were trembling. His voice was quiet. And within 5 minutes of him speaking, I put down my pen. I sat back, and I did not move for 40 minutes, because what Bernhard Riemann was writing on that blackboard, I had never seen. Not in 60 years. Not from anyone. I had read his doctoral thesis 3 years earlier. I had called it the most important mathematical work I had ever seen. I thought I knew what this man was capable of. I was wrong. What Riemann showed me that morning was not mathematics. It was a door, and behind that door something so deep, so vast, so completely beyond what any human mind has reached, that 165 years later, the greatest mathematicians on Earth are still standing in front of it, with a $1 million prize for anyone who can open it. No one has claimed it, not one person. What was inside Bernhard Riemann's mind was not from this world. I want to tell you something about Riemann, and before I tell you what he did, because when you hear what he discovered, you will ask yourself the same question I asked myself that morning in that lecture hall. How does a human being see this? Where does it come from? And I need you to understand where he came from, so that you understand why the answer is so difficult. Most people who change mathematics come from wealth, from libraries, from fathers who were professors. Riemann came from none of that, and I think about that often. I think about what it means, that the most profound idea in the history of mathematics came from a boy who grew up in a house with no heat in winter. His father was a pastor in a small village in Lower Saxony. 6 children, almost no money. Bernhard was the second child, born in 1826. In a place so small, so forgotten, that you will not find it on most maps today. He was sickly from birth. His mother died young. He was so shy that he could not speak to strangers without trembling. He taught himself mathematics from books he borrowed. As a teenager, his school director gave him a book, Adrien-Marie Legendre's Théorie des Nombres, 859 pages. Riemann returned it 6 days later. The director asked him if he had read it. Riemann said, "I have mastered it." He was not lying, and I want you to remember this moment, because this is who wrote those 8 words. Not a man from a great university, not a man with money or connections. A boy from a village with no heat who mastered 859 pages of mathematics in 6 days. That is who left a problem that no one has solved in 165 years. I have been called the Prince of Mathematics. I do not say this with pride. I say it so you understand what it means when I tell you. When I first read Riemann's doctoral thesis in 1851, I felt something I had not felt in 40 years of mathematics. I felt that I was reading something I could not have written myself. He was 25 years old. His thesis redefined what a function was, not improved it. Redefined it, the way you redefine what the word number means. What he built in those pages, mathematicians are still using today in quantum physics, in fluid dynamics, in the mathematics behind every computer screen you have ever looked at. And that was just his first paper. To become a professor at Göttingen, a young mathematician had to give what we called a habilitation lecture. You submitted 3 possible topics. I had to choose one of the 3. I was on the committee. The tradition was to choose the first topic, the one the candidate was most prepared for. I chose the third. I do not know why I did this. I have asked myself many times. Perhaps I wanted to see what he would do when the ground was taken from beneath him. Perhaps I already suspected what he was capable of. Perhaps, and this is the answer I return to most, I simply wanted to hear what Bernhard Riemann would say when he was forced to reach deeper than he had planned. The title of the lecture he had to give, On the Hypotheses which lie at the foundations of geometry. He had almost no time to prepare. On the morning of June 10th, 1854, I walked into that lecture hall and sat down in the front row. I was 77 years old. I had attended perhaps 10,000 mathematics lectures in my life. I expected to be politely interested. I expected competence. What I did not expect was to sit completely still for 40 minutes, unable to speak. Riemann walked to the blackboard. He began to speak, and within 5 minutes, I understood that he was not giving a lecture about geometry. He was dismantling it. Everything we believed about space, that it was flat, that parallel lines never meet, that the shortest distance between 2 points is a straight line. Riemann showed that these were not facts. They were assumptions. Assumptions we had never questioned because we had never needed to. He then built, from nothing, a mathematics of curved space, of space that bends, of space that is different at every point. He had no physical reason to do this. No experiment had suggested it. He did it purely from thought. 60 years later, Albert Einstein used Riemann's geometry to describe how gravity bends space itself. General relativity, the theory that explains black holes, the expansion of the universe, the GPS in your telephone, is written in the language Riemann invented that morning, in 1854, before Einstein was born. When the lecture ended, I did not applaud immediately. I sat still for a moment. I was looking at this young man, thin, nervous, trembling slightly, and I was thinking, one thing. What else does he see that we cannot? I did not know then what he would write 5 years later. I did not know that the greatest question in the history of mathematics was still inside that trembling young man's mind, waiting to be released, and that when he finally released it, he would not be able to finish it himself. 8 months after that lecture, in February 1855, I was gone. But the story was not. I did not see what Riemann did next. But you need to know it, because what I showed you, the geometry, the lecture, the blackboard, was not his greatest work. What I am about to tell you is the reason you are still watching. It is the reason $1 million is sitting unclaimed. And it begins with the simplest objects in all of mathematics. Prime numbers. Numbers like 2, 3, 5, 7, 11, 13. Numbers that cannot be divided by anything except themselves. And 1. Prime numbers are the atoms of mathematics. Every number that exists is built from primes. And for thousands of years, mathematicians had asked the same question. Is there a pattern? Do primes follow a rule, or are they scattered through the number line like stones thrown by a child? I spent years on this question myself. Starting as a teenager, I counted prime numbers in blocks of 1,000, all the way up to 3 million. A lifelong obsession. I found that as numbers grow larger, the primes appear less and less frequently. But how much less frequently? Is there a precise rhythm hidden inside the chaos? A law that tells you, at any point on the number line, exactly how many primes you should expect to find? I could not answer it. Riemann said there is a pattern, and he found a way to describe it that no one had imagined. He built something called the zeta function, a mathematical machine. You feed it a number, it gives you back another number, and for certain inputs, the machine outputs exactly 0. Riemann called these points the zeros of the zeta function. Now here is what stopped him, what stopped every mathematician after him. When Riemann calculated these zeros, he noticed something that had no right to be there. They were not random. They lined up. Every single zero he could calculate sat on a single straight line running through the mathematical plane. Not most of them. All of them. He made a claim that this was not a coincidence, that all non-trivial zeros, every one of the infinitely many zeros of the zeta function, lie on that one line, what mathematicians now call the critical line. He called it a hypothesis, not a theorem, not a proof. A hypothesis because he could not prove it himself. And then he wrote those 8 words. This, however, I have left unproven after several fleeting attempts. I want you to sit with those words for a moment. The boy who mastered 859 pages of mathematics as a teenager. The man who invented an entirely new geometry in a 40-minute lecture. The man whose work Einstein would use 60 years later to rewrite physics. That man looked at this problem, tried several times, and wrote the words, "I cannot do it." That is not a small thing. That is the boundary of what one of the greatest minds in human history could reach. And the reason it matters goes beyond mathematics. The pattern of prime numbers is the foundation of modern encryption. Every time you use a bank card, every time a hospital stores a patient file, every time a government sends a classified message, the security of that information depends on the fact that prime numbers are unpredictable. If the Riemann hypothesis is proved, and if someone found a way to use that proof, the entire architecture of digital security could be transformed overnight. Riemann wrote 8 words in 1859 and walked away from a problem that sits at the heart of how the modern world works. Riemann died 7 years later, in 1866. He was 39 years old, tuberculosis in a small village in Italy, on the shore of Lake Maggiore. His housekeeper, not knowing what she was doing, discarded most of his unpublished papers after his death. We do not know what else he had found. Since 1859, every major mathematician has tried. David Hilbert, perhaps the greatest mathematician of the 20th century, listed the Riemann hypothesis as the most important unsolved problem in all of mathematics. He once said, if he could sleep for 1,000 years and wake up, the first question he would ask is whether the Riemann hypothesis had been proved. He never saw the answer. G.H. Hardy, the man who discovered Ramanujan, spent decades on it. He proved that infinitely many zeros lie on Riemann's line. Not all of them. Infinitely many. It was the greatest progress anyone had made, and it was not enough. Today, computers have verified that the first 10 trillion zeros all lie exactly where Riemann said they would. 10 trillion confirmations, 0 exceptions, and still, no proof. I want you to think about what that means. 10 trillion pieces of evidence, every single one pointing to the same answer. And the mathematics still refuses to yield, as if the proof exists in a place that human logic cannot yet reach. In 2000, the Clay Mathematics Institute offered $1 million to anyone who could prove or disprove the Riemann hypothesis. 25 years later, the prize has not been claimed. The problem that Riemann could not finish, that he left behind with 8 words of apology, remains exactly where he left it, on the edge of what we can know. I still think about that morning in the lecture hall. A young man, 27 years old, hands trembling, voice quiet, writing mathematics that described the shape of space itself, 60 years before anyone would need it. And somewhere inside that same mind, a question about prime numbers that no one has answered since. I was the prince of mathematics, and when he finished speaking, I could not move. I do not know if the Riemann hypothesis will ever be proved. I do not know if human mathematics is yet deep enough to reach it, but I know this. The man who asked the question was 33 years old. He had tuberculosis. He had almost no money. He was working in a language, the language of the zeta function, that he had largely invented himself. And what he saw, what he reached for with those 8 words, is still out there, waiting for someone whose mind, like Riemann's, sees from somewhere else.